Okay.
Good, thank you. So, again, we have a linear total revenue, just like we derived here, and let's now graph the total cost snake in the same graph. Okay. Now, if you're asking me why are those two curves related to each other in this particular way, does it always have to be like that? I tell you, no, it doesn't have to be like that. We're going to eventually explore all kinds of possibilities. But this is not a bad way or bad point to start with. So let's suppose you're running a firm like this, a firm with this total revenue and a firm with this total cost. What quantity are you going to produce? You got into business to not just make money, but make as much money as you could. Let me ask you, are you going to be actually producing quantity Q1? Yes or no? How much profit would you generate if you produce quantity Q1?
Not that much.
Try and be more specific. How much? This is your revenue. So that's how much revenue you will make. That's also the cost. It costs you to bake that pizza, if this is how many pizzas you bake, right? How much profit are you making? Meaning zero. Zero profit, right? Is that the best you can do? Or you think you could actually generate more than zero profit if only you changed the number of pizzas or the amount of pizzas you bake? Should you bake less or bake more?
More.
More. Because only if you bake more, you will generate bigger revenue than the cost of baking, correct? In other words, you are telling me to bake more. Everybody heard that, right? Your colleague suggested, let's bake more pizza. I will do exactly what you said. I'm going to bake more pizza. I'm going to bake Q2 pizzas. Is that more than Q1? Is Q2 more than Q1?
Yeah.
Yes. Am I making more profit? No. I'm still making zero profit. You told me I should bake more pizza to increase my profit. I did that. I baked more pizza, yet I didn't increase my profit. So what you're suggesting is not just that I bake more pizza, but that I bake a certain particular quantity greater than Q1 and definitely smaller than Q2, right? And which I'm not just making positive profit, I am making maximum profit. But how am I going to find that quantity, guys? I mean, I could try this quantity.
The distance between those 2 points.
I would make this much profit, right? The distance between those 2 points, vertical distance between those 2 points would be the profit. I could produce this quantity here. And I would be making this profit, right? Distance between those 2 points. That's a positive profit. This is a positive profit. Is that what I should bake? One of these two dotted quantities? Or can I do better?
It should be in the middle.
Does it have to be in the middle?
Well, when you maximize your profit by doing that?
It may or may not be in the middle. It's definitely somewhere in between, right?
Well, I mean like the gap in between.
Bingo. In other words, I'm looking for a quantity at which the gap between revenue and cost, total revenue and total cost, is the largest. Because the gap between the two is the profit, right? My question is, how are we going to find the quantity at which that gap is maximized, at which the profit is maximized? How are we going to find it? Let me give you a hint. Let's say you love climbing mountains. Why? Because you love being on top. So you go for a hike. You find a mountain and you're climbing on that mountain. Okay? And you're climbing. And your goal is to climb to the very top. How do you know that you reach the top?
You're on top.
You're on top. But how do you know you're on top? How do you recognize top of the mountain from a side of the mountain?
You're at its peak.
Say it again?
You're at its peak.
You're at its peak. What's true at the peak that's not true anywhere else on the mountain?
You can see everything.
It's the highest point. In other words, no matter where you stand, you cannot get any higher, right? In other words, it's the only point on the mountain where you're not going to go up, you're not going to go down. It's as if you stood on something that's flat. Is that true? All right. Let me ask you a different example. Suppose you are Frodo Baggins. You're climbing down that volcano after your finger has been bitten off by the spooky dude, right? You're going down that, you're walking down that mountain. There's lava everywhere. You're worried you're gonna get burned down. You luck out, you find a stone. There's this big stone here, right? And so you climb on top of that stone to save your behind. Now you feel that lava heat rising. So what you really want is to find the point on that stone where you are as far away from lava as possible. Is this the point you want to sit at? Are you really far from the lava below you? No. The lava is only, a few feet below you, right? If you move further away down that rock, you will eventually find a spot where you're really far away from the lava. And the rock is still relatively cool, right? My question is, how do you find a point on that rock at which you are the farthest away from that lava? Let me give you a hint. Does that make any sense? In other words, you want to find a spot on that rock at which tangent to the rock is parallel with the tangent of the slope. That makes sense? And at that point, you found the greatest distance from the ground below. Use that analogy here. How do we find quantity at which vertical distance between total cost and total revenue is the greatest?
In the middle.
It may or may not be in the middle, but it sure will be at the quantity at which tangent to total cost touches total cost and is parallel with total revenue. And that's the quantity, it's not exactly in the middle, that's the quantity where you maximize the profit. I will call that quantity Q star, the profit maximizing quantity. Okay? And it's the quantity at which profit is the greatest. Let me now use just a minute to give you a quick hint where we go with this on Thursday. Please don't go quite yet. On Thursday, I will revisit this exact example. And I will ask you, what will happen to this firm? What will this firm do if price of pizza increases from $10 to $12, and I will show you that when price of pizza increases from $10 to $12, total revenue becomes steeper. And as total revenue becomes steeper, you will maximize your profit at the quantity where the tangent is going to be steeper. But if you want to make the tangent steeper, you're going to slide along the total cost curve. In which direction? To the right or to the left to make tangent steeper? To the right, corresponding to a greater quantity. In other words, this explains to us that when price of pizza increases from $10 to $12, profit maximizing company will do what? Bake more pizza. As price of pizza goes up, firm is willing and able to produce more pizza. As price of pizza goes up, firms are willing and able to produce more pizza. What does that tell you? That supply curve is upward sloping. Does that make sense? That's where we're heading with it. Thank you so much for your attention. I'll see you in person.